Chapter 4 will start with finding the growth and decay percentages. Now, to find out where growth and decay are or how to figure that out, the key here is this number right here, okay? So the number in the parentheses is going to tell you everything you need to know about whether this is a growth function or a decay function, okay? This 570 here, that's called the initial amount. That's not really going to be important to us just yet, but just so you know, 570, whatever number's in front of the parentheses, that's the initial amount. Okay, but here's the key. Okay, is it growth or is it decay? Well, 1.01, that's the number in parentheses, that number is greater than 1. So what that means is we have growth. Okay, so that's the answer to the first part, because it says identify whether the change represents growth or decay. Well, it's growth. Now we need to determine the percentage rate of increase or decrease. Well, how do we do that? Well, this function, kind of like the main function here, is a times 1 plus r to the x power. Okay? R is the rate. Okay? Now that rate, that's the percentage. Okay? And again, A is that initial amount. All right? So, what we want to do is, okay, since 1.01 is bigger than 1, to figure out the rate, what we want to do is 1.01 minus 1, okay? Because we want to find out how much more 1.01 is than 1. So our answer is 0.001. So that would fit right here in my formula. So what that means is that R is 0.01. Well, as a percent, you move it 2 decimal places to the right. So we have a 1%, and since it's growth, it's a 1% increase. Okay? So when you're given something like that, the key is the number in the parentheses. Okay? Now, the second problem, okay, same thing, and we have the same looking problem, but here's the difference. Look at the number in the parentheses. So 0.909 is less than 1. So this is decay. All right? So when we want to know what decay is, okay, R, so again, we're going off of, now we're doing 1 minus R, because that's decay, all right? So it's going to be 1 minus 0.909, okay? So for growth, we minus 1. For decay, we do 1 minus. So what we have here, so 1 minus 0.909 is 0.091. Well, if I move the decimal point 2 to the right, I have a 9.1% decrease because it's decay. All right, decay means decrease, growth means increase. Okay, notice the differences here. All right. For decay, it's 1 minus. For growth, it's minus 1. Big difference. Okay, now, they are going to give us some different type of problems, okay? So, same thing, okay? We need to determine decay or growth, all right? Now, in this problem, we have y equals 2 to the negative 5x. Well, what we have to do is we need to figure out what 2 to the negative 5 is. Now, we did this in Chapter 3 with the power to a power. What I can do is I can put 2 to the negative 5 in parentheses and just raise that to the x, because remember, if I do this, negative 5 times x is negative 5x. So I'm just splitting it up. So calculate 2 to the negative 5. Okay? So if I do that, I get 0.03125 to the x power. Okay? Now, again, number in the parentheses. All right? 0.03125 is less than 1, so it's decay. Okay? Well, to figure out what the decay is, I do 1 minus. So actually, let me do this. Whoops. So R, which is the rate, is 1 minus 0.03125. Okay, so I get 0.96875. Okay, so I take the decimal point and I move it 2 to the right. So that's 96.875%. Now, it says determine the percentage rate of increase or decrease per unit of x to the nearest tenth of a percent. Well, here's tenths. 7 is going to bump 8 up to 9. So my final answer is 96.9% decrease because it's decay. All right. So we're going to be looking at some different looking functions, but they're not really difficult. As long as we have calculator, we'll be fine. Okay, here's a different looking one. Same thing though. Okay. So what I need to do, the first thing I need to do is calculate 1 plus 0.068 divided by 12. I need to put that in my calculator. Okay. So when I do that, and I've already done it, I get 1.05, I'm sorry, excuse me, 1.0056667 to the 12x. Okay, notice the power doesn't change yet. Now, once we've done that, then we're going to move the 12, now that we've done that, we're going to move the 12 inside. Okay? So, now we're going to calculate 1.005667 to the 12th power. So, I get 1900 times 1.071 or 15988 to the x power. Okay. Now, it's all about the number in the parentheses, guys. Once we do that, okay, so 1.07015988 is bigger than 1, so this is growth. Okay, so I take 1.07015988 and I subtract 1, and that gives me this. But if I move it 2 to the left, I get 7.01%. I don't really care about the rest of the numbers, okay? Because it says round to the nearest tenth. So I don't really care about the rest of these numbers. So here's my tens place. Does 1 do anything? No. So it's 7% increase. So notice there's 2 things we have to calculate before we determine growth or decay. All right, now, E. Okay, E is a number. Okay. E is approximately 2.72, blah, 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 blah. All right. There's going to be, hopefully, I think there's a button in Desmos that you can press to get E. To do this is just like, I believe, number 3. So we have y equals 1100 times e to the negative 0.216 to the x. So we split the exponents apart. Okay? So I need to calculate e to the negative 0.216 power. Okay? So I do that, and I get, what do I get here? 0.80574. I rounded to 5 decimal places because the decimal's super long, to the x. Okay? Now, again, here's my number. So 0.80574 is less than 1, so it's decay. So 1 minus 0.80574 is 0.19426. Well, if I move the decimal 2 to the right, I get 19.426%. Here's tenths. What does 10 do, or 2 do? Nothing. So my final answer is 19.4% decrease because it's decay. Okay, so more working with exponents, we're actually doing the opposite of what we did in chapter 3. Okay. Okay. Now, we talk about the last 3. All right. Now, again, same thing. There's a lot going on here, but we're doing a lot of the same thing. It's e to the 3 ln 0.58 to the x power. Ln stands for natural log. We're going to talk more about that when we get into logarithms later this year. Don't worry about it right now. Just look for the ln button on your calculator. So we need to calculate e to the 3 times ln 0.58. So if I do that, I get 0.195112 to the x power. Okay? So again, 0.195112 is less than 1. So we have decay. So R equals 1 minus 0.195112, which is 0.804888. Move it 2 to the right. So I've got 80.48%. Here's my tenths place. 8's going to round it up. So I have an 80.5% decrease. So all we're doing is manipulating these equations. That's all we're really doing here, okay? Okay, same thing here. Okay, we have another situation. So we're going to take the negative 8 and we're going to move it inside. So it's 1.1 to the negative 8 to the x power. All right, so we put that in our calculators. So again, we are calculating 1.1 to the negative 8 power. So that gives us 0.46651 to the x. Okay, this is less than 1, so it's decay. So the rate is 1 minus 0.46551, or 6, that's a 6, sorry, which is 0.53, 349. So if I move it 2 to the right, I get 53.34%, but that's just 53.3% decrease. Because again, here's my 3, 4 does nothing. Just manipulate, and these are all the different types of problems you're going to see. Now for this one, okay, as you can see, there's an x on top of the fraction. So this is another way we could write it. Okay? See how this is negative x over 7? Well, I can rewrite that as negative 1/7 x. Okay? Now I just do the same thing I've been doing. So it's 600 times 2 to the negative 1/7, and the x is on the outside. Okay? So I calculate that, and I get 0.90572 to the x. Well, that's less than 1, so it's decay. So 1 minus 0.90572 is 0.09428. So I move it 2 to the right. I get 9.42%. Here's my tenths. 2 does nothing, so I have a 9.4% decrease. Okay? So, sorry that was a little lengthy, but there's 8 different types of problems that you might see in the delta math. I wanted to show you an example of each one.